Welcome to our notes on finding corresponding points of polar coordinates. Students will be able to describe in words how to find equivalent polar coordinate points given an angle and radius restrictions. Part 1. Mark up the steps for finding two equivalent polar coordinates for the given rectangular coordinate xy. Step 1. Plot the given rectangular coordinate -1, square root of 3. So I need to know approximately where the square root of 3 is. I know it's going to be closer to 2 than 1 because the square root of 3 is really close to the square root of 4 versus the square root of 1, which are our perfect squares. So it's approximately 1.732. So I'm just going to plot that right now. Since my x and y scales are 0.5, this makes it really easy for me. So I'm going to be around here for the square root of 3. So this is going to be my point. I'm going to call it P. And then I'm just going to draw a line from it to the origin to help me visualize. Note, the given rectangular coordinate is where the positive radius of the polar coordinate is. The negative radius is in the quadrant diagonal from the rectangular coordinate with the same reference angle. Step 2. Find the radius using the formula x squared plus y squared equals r squared. If we solve for r, then we're going to end up with plus or minus the square root of x squared plus y squared. My x is -1, and my y is the square root of 3. So after doing some math, I know that the inside is going to be 4 and the square root of 4 is 2. So r is plus or minus 2. Step 3. Find the angle using the formula theta equals inverse tangent of y over x. So if I were you, maybe find in degrees first. And then convert to radians later. Okay, so my y is the square root of 3 and my x is -1. Now this square root of 3 and 1 stuff kind of reminds me of special right triangles, so I'm actually not going to use my calculator for this, but remember, if you were to draw this out, the 30, 60, 90 triangle, you won't be able to do this for all problems because, you know, unless it's a special one like square root of 3 or square root of 2, those kinds of things, you won't be able to do that. So tangent of 60 degrees will give me root 3 over 1. So I know that my reference angle is 60 degrees. Because the inside of this inverse tangent is negative, I know it's going to put me at -60 degrees. You can actually use your calculator to verify that if you need to. But just be careful, okay, because that's not always the angle you need. -60 degrees is in the 4th quadrant. However, my rectangular coordinate put me in the 2nd quadrant. So I must add 180 to this angle. So -60 plus 180 equals 120. All right, so step 4 says form the polar coordinates using the radius and the directional angle, right? The final answer in radians. So we have from step 1 plus or minus 2. So my positive radius is going to go with my angle of 120 degrees. My negative radius is going to go with the -60 degrees. Okay, so if I just convert to radians, this is 2 pi over 3, and this one is -2 pi over 3. Step 5, find all equivalent polar coordinates in radians. So I'm always going to have a positive and a negative radius, and the thing is that if I have one polar coordinate, I have one of the angles, right? So 2 pi over 3, I need to get back to an angle that's equivalent to 2 pi over 3, and that goes back to our coterminal angles where we add 2 pi n, where n is an integer. Also, I can start at -pi over 3 and I can add 2 pi n to that, where n is still an integer. And these are all of the equivalent polar coordinates in radians. The algebraic box says convert the following rectangular coordinate into two polar coordinates for theta between 0 and 2 pi. So the first thing I'm going to do is I'm going to find r, which is equal to plus or minus the square root of x squared plus y squared. When I simplify that, I get plus or minus 4. All right, next I'm going to find theta, which I'm going to use inverse tangent of y over x. I see that I can simplify this fraction, so I'm going to go ahead and do that. This is equivalent to 1 over the square root of 3, which I am again on my special right triangle, the 30, 60, 90, which we drew already. So when all is said and done, that's going to end up being 30 degrees, which I can rewrite as pi over 6. Now, the problem is I know that this rectangular coordinate is in quadrant 3, but pi over 6 is in quadrant 1. So I must add pi to it, or 180, depending on which one you're working in. So if you add 180 to 30 degrees, you get 210 degrees. And if you add pi, here I'll write it like so. Pi is 6 pi over 6. So I can add these fractions, you get 7 pi over 6. And 210 is the equivalent of 7 pi over 6 in radians. All right, so I'm going to use the radians for my final answer. I want the positive radius to be where I actually am, so positive 4, with the angle 7 pi over 6. So that means negative 4 will be with the angle pi over 6. All right, so here's the graphical. I'm not going to label every single one of these things, but I always like to label the, the quadrant angles. And I will go ahead and label where 7 pi over 6 is. 7 pi over 6 is actually going to be here. So I'm just going to use a highlighter this time because sometimes it can be easy to get lost. I know I'm going to be on this. So I need to go 4 units out. So 1, 2, 3, 4. I'm actually right here. So this is the polar coordinate. And both of these are in the same spot. So there we go. There's the graphical part of this. Now let's move on to the numerical. So the numerical directions say find additional equivalent polar representations for which r, the radius, is positive and theta is between negative 2 pi and 0. So if r is positive, then I'm going to take the positive 4, which means I'm going to start with angle 7 pi over 6, and then I'm going to subtract 2 pi, which I'm going to write as 12 pi over 6. 7 minus 12 is negative 5 pi over 6. Okay, well 7 minus 12 is negative 5, but then, I have the pi over 6. So that is the polar coordinate that I am looking for. So now I'm going to find another polar representation for which the radius is positive, and now theta is from 2 pi to 4 pi. So because I'm taking the positive radius, I'm going to start with 7 pi over 6 again, and this time I'm going to add 2 pi. So this will put me at 19 pi over 6, and this is the equivalent polar representation I'm looking for. All right, now I want to find yet another one. This time I want my radius to be negative. So because of that, I knew my pi over 6 went with my negative radius, so I'm going to start with pi over 6. And it says I want my theta to be from negative 2 pi to 0. So I'm going to subtract 12 pi over 6. So that puts me at negative 11 pi over 6. All right, so why don't you do the verbal? It says, in your own words, write the procedure for finding equivalent polar coordinates.